So this class is for vector. Vector is, it is defined like this. You have got in physics vector. So mechanics, everything in physics you have to do with vector. So a quantity that has magnitude, it is defined like this. So it is having magnitude as well as direction. And magnitude, so that is, so this arrow mark, it is a cap in this letter A. So this arrow mark means this is a vector. It is having magnitude. Magnitude we write it as modulus sign. Write it like this, modulus of this. Then different types of vectors are there. Zero vector, null vector. Zero vector, null vector is its magnitude 0. Then unit vector. Unit vector is this. Some vectors are given. Then you divide by the modulus of this. Then you will have this modulus is equal to 1. So this is the unit vector. Unit vector speaks about the direction of the vector, direction of the vector. And collinear or parallel vector, two vectors are collinear or parallel if they are equal. Equal means equals are equal in component. Then position vector of a point. So this is the coordinate system. So suppose P is having coordinates x, y, z. Then OP is as you have got in the three-dimensional geometry. So P projection of P on x axis, this is x, projection of P on y axis, this is y, and projection of P on z axis, this is z. So this x, y, z. So you go along x axis in the direction of I, in the direction, this is unit vector I, j, k. So there are three mutually perpendicular, there's three directions, and this x is along x axis because we are considering three mutually perpendicular. So we consider coinciding with the axis. So x axis, along x axis it goes I, along y axis it goes j unit, this direction is j, and along z axis it goes z unit. So this is, so OP. So this is position vector. So position vector, how will you get it? We are first we start from O and then we reach P. So this is the direction. Actually, when you are to, when you so suppose it is the this is the starting point A, then A, this is a vector, this is this, from this A you go along this direction, this is a B, this is, and you are having, and you are getting this, say B point, and then this sum of these two vectors, we just this join this, we just join it, the starting point and the last point. So this is a vector AB, it is A, this vector plus this vector, and this go at this. So in this P, this is also, so O point is the starting point, then you xi you are coming, then you yj, then you zk, and you are getting this. So it is a sum of xi, yj and zk, and it is a vector OP. So this is our position vector. Then direction cosines. The direction cosines like straight line, and this is direction cosines. We have the angle made by projection of the vector on x axis. It is OP cos alpha or R cos alpha. Suppose R is a vector, so R cos alpha is the projection, and this is x. So cos alpha is, as that you have got in three-dimensional geometry. This cos alpha, cos beta, cos gamma, these are direction cosines, and it is given by x by r. So in this diagram, you see this diagram. So is OP. You this draw projection here. So this is OP cos alpha. So this is OP cos alpha. So P this is perpendicular to y axis. Sorry, x axis. So OP cos alpha is equal to x. Similarly, OP cos beta is this one. This one OP cos beta. So this is equal to this. So it is y, and OP cos gamma OP cos gamma is this one. So this is OP cos gamma. So this is Z. So these are direction cosines, cos alpha, cos beta, cos gamma. So LMN are direction cosines. Then so because direction cosines, these are proportional, because this ratio is L is to X. This constant, it is given in terms of magnitude of R. Magnitude of R we are having. So this X, Y, Z we say direction ratio of the vector is similar to this concept, same concept. Next is resolution. So resolution is R vector along 3 perpendicular direction. We are taking x, xi, yj, zk. So these are resolution. If we want to, suppose this is a vector, this is a vector. Suppose in this direction we are to we are to mix, we are to have component in this direction. So you just measure this angle theta, then this cos theta. So this is the component along. So this, it is R, this is R cos theta is the component along this direction. So these are resolution. Then addition of vector, just add the components, this is addition of vector, then addition of vector, then product of vector. So this is R1, R2. So we are adding this. So R1 parallel to, so this R1, this is R1, it is parallel. Then this direction. So this starting point, you join it, join with the this end point of this vector. Then in the same direction, so these two are parallel. So same direction is getting so going. And so this is from starting point to this, directly you join it, and this vector is R1 plus R2. Similarly, R1 for R1 minus R2. So first you consider R1, then in the opposite direction of R2, you bring it, and this is R1 minus R2. So this is subtraction. So it is just algebraical addition and subtraction, and coefficients are coefficients of I, J, A, K. Then products, two types of products are here. So dot product. Dot product is actually dot product is defined as magnitude of this vector if I take the product, and then cos of theta, where theta is the angle between the two vector, and this is given by R1 x1 x2 plus y1 y2 plus z1, because I dot j. So if you this suppose this is x1, so this dot this, so this vector dot this vector, then x1, so when you are to multiply this, so x1 I into x2 j, so I dot I is 1, so it becomes x1 dot x1 into x2. Then I dot j is 0, so this from this we are getting, so from this we are getting R1 dot R2 is equal to this one. And for cross product, you have to use this thing, I cross j. I cross j is this we are using. I cross j is k, and order is important here. So if we say I cross j, then it is k. If we say j cross I, then it is minus k. So I cross j cross k. So it is cyclic. So I cross j. So I j k. So I j k. যদি আমি I কে j কৰোঁ তেতিয়াহ'লে আমাৰ এইটো ডাইৰেকশ্যনটো চেঞ্জ হৈ যাব, so like that. Then projection of vector. So projection vector is, as we have got it, it is AB cos theta. So AB cos theta, because we require this one, A, B are two vectors. So A cos theta. So A cos theta means, so this is a vector, this is A, this is A in this direction, suppose it is B. So A cos theta, we only require this one, A cos theta. So A cos theta means A dot B, it is this definition, A dot B is this. A dot B. So we require only A cos theta. So you make it 1. You make it 1. So we consider this dot product along with the unit vector. So that this becomes 1 and this is R1 cos theta. So we take this unit vector along B. Along B you take the unit vector. So our projection is A dot unit vector of B. If we say a projection of say B, so suppose this is a vector B, so this is vector. If we say projection of B on A, then this is perpendicular. So this will be your B dot unit vector along A. So these are different. And then angle between two vectors, it is A dot B, the dot product is, we have to consider unit vector, because if it is not unit vector, then we will have the x1 x2 components, etc. But it is a unit vector, then its modulus is 1. So we consider a unit vector, and then we have the cos theta. Then two vectors are parallel if they have same directions, direction cosines. So parallel cosine, direction cosines are same. That you have got in this geometry, and two vectors are mutually perpendicular, and if their dot product is 0. So same direction cosine, actually this one cross product will come from cross product. So cross product is given by R1 cross R2. So this is sin theta. So theta is 0, then it is cross product is 0. So cross product is 0 means what? This is a determinant. So x1 y1 z1 x2 y2 z. So this determinant will be 0 when? Because ijk is not 0. So this will be 0 if they are identical or they are proportional. So that is why their direction ratios are proportional, or they have the same direction cosines. You remember, direction cosines are unique, but direction ratios are proportional. Then section formula, similar to that, you have got it. Then work done. Work done. This application, it is work done. So this is F is applying this force. So it is moving to this. So it is F cos theta into D in this direction. In direction, so you have to consider this component. So that is why it is F dot D. It is the dot product. It is dot product. This distance R, it is moving, so it is F dot R. And this one is for cross product application. The cross product application, it is when you apply a force on some P at the point P. So you are applying some force in this direction, then. So this is the P, and about we are measuring moment about some point or some line. First you have to know the moment about point. So O is the point. So this is the cross product, and the actually cross product vector, cross product of two vectors, it will have direction perpendicular to the plane of this. So R F is, this is the plane containing this one. This is the plane containing this, and this force, this moment, it is a vector. This goes along this line. So these are the applications. So moment is for cross product, and work done is for dot product. So these are all about this theory, and you see now the examples. So examples. Find the unit vector. So unit vector is, you take the modulus. Modulus is root over 4 square plus minus 3 whole square plus 2 square. So this is modulus. A square plus b square plus c square root over. Then divide by this one. Then direction cosines. So we have worked out here. Number 1. So these are solutions. So this is a vector, then it is unit vector is we are dividing this by the modulus. So so this is the vector. This is, so if you find the modulus of this, you will have 1. Then this one is same problem, same procedure. Then direction cosine. So direction is actually unit vector. Unit vector, these components are direction cosines. So this is a vector. So these components 4 minus 3 2, these are direction ratios. But when it is unit vector, then the components are direction cosines. It is unique. It is unique, and this is direction cosine. So this is number 2. You have to find direction cosine. So it is a unit vector, and these are the components. Then the direction cosines. Then unit vector along. You have to find unit vector along this. And what about this? Number 3. What was that? Number 3. Find a vector. So find a vector of this of magnitude 15 means what? Your direction. So this is a vector. Suppose this is a vector 3i plus 3j minus 4k. Then magnitude, magnitude may not be 15. So you require a vector of magnitude 15 means its length must be something. Direction is this one 3i plus 3j minus 4k. But you require to modify this length. So that is why, so direction is given by the unit vector of this. So direction, so you find a unit vector and then multiply by 15. Then its modulus will be 15. So that is the way to find this. So the unit vector, so vector along this, so magnitude 15, you are multiplying by this 15. So this is a vector. So this is a vector whose direction is this and magnitude is 15. Similar way. So first you find the unit vector and you then multiply by this. And in number 4, you have to find different things. It is first thing for a plus b, you have to find unit vector along a plus b. So a, b, c are given. A, b, c are given. You have to find this a plus b, unit vector along a plus b. This is unit vector along this. So you see the question. Number 4. So a, b, c are given, unit vector along this unit vector. So first you add these two. So add this a plus b is given by this plus this plus this. You components you add. And this unit vector along this. So you add this, then you find the unit vector perpendicular to a and c. Perpendicular to a and c means it is the plane containing. So if it is a, it is c. So you will have, so you take to this. So so you make them intersect, so this slide, sliding this you will take here. So this plane contains this a and c. It is containing, and the unit vector, so it is a cross product perpendicular. So unit vector, it is perpendicular to the plane of the plane containing a and c. So unit vector, when you are to unit vector is this is, you take the cross product and that you will have a vector perpendicular to the plane, and that is this direction you will get the unit vector perpendicular to the plane and perpendicular to a and c. Similar, number 4 is containing plane containing 2a and b. Same problem. You take the cross product and take the unit vector. Then here you have to find this cross products. Then this is cross product and dot product. This dot product. These are just computation and direction cosines of this. projection. Number 4. So these are, we are adding these things. This you see, a minus b. It is one. So first you find a minus b. A minus b is this. Then to make the cross product, so this order. So cross product is ijk. Then a minus b is prefactor. So we are writing this in the second row. So it is components of minus 7, 3, minus 7. Then C. C components of C is CR 3 minus 6 minus 1. And then like multiplication of determinant, you find this value and you will have this one. Then modulus, so you add C plus B and then you take the modulus of this. Next problem is number 5. Number 5 is what? Parallel. So parallel vector. So two vectors are parallel if they are proportional. So you are finding P equal to this. Then force. Number 6. So two forces are applying at a particle. So two forces are acting simultaneously. So this is one force. So particle is same. This is one force. One force is F1 and this is another force F2. So two forces are acting. So in which direction it will go? It will go in the direction somewhere here. So this is F1 plus F2. Actually this will be as, so this is F1. You complete a parallelogram. You complete a parallelogram and this parallelogram you are completing. So this force is F1, this force is F1, this is F2, this is F2, and this diagonal is F1 plus F2. And just you add algebraically, so it will give in this direction. So this is F is F1 plus F2 acting on this. So total force is this. We are displacing D unit, D vector. So you consider the work done, and this will give you the this. This is just you just write unit because no units are given for your force or displacement. Nothing is given, so you just write unit. Then force, etc. etc. Same problem. And number 8 you see force of magnitude 10. So magnitude 10 means you have to find a force in this direction. So find a unit vector along this, then multiply by 10 and you will have the vector F1. So this is, so you take the unit vector. So you take the unit vector then multiply by 10, you will have in this force F1. Similarly you will have another force F2 and they are acting. Then number 9, 10, these are about moments. So this is, we are all simple problem. So O and P are given, force is given. So you just find OP is equal to R. OP is equal to R. Then you have to take this cross product. So it is IJK. Then prefactor is R. So this component R, you have to write this is R. And this is R cross F, this is force. So in the third row you write components of force and you will simplify it and you will get the moment of the force. So this is all about the vector. Very simple, very basic problems. You just go through this thing and any problem you discuss with me, you ask me, I will clarify you. Thank you.